Hi, my name is Samantha Leech, and this is my presentation on ozone depletion and its effects on amphibians for chemistry and society. I will briefly discuss stratospheric ozone and the ozone hole as we have already covered it in class. O3, or ozone, is a molecule consisting of 3 oxygen molecules bonded as such. In a 24-hour period, hundreds of thousands of tons of ozone molecules are created and destroyed, resulting in a relatively steady amount of the compound. The 4 steps of the Chapman cycle show how these molecules are created and destroyed. A photon with a wavelength equal to or shorter than 242 nanometers can break the bond between 2 oxygen, resulting in a free radical oxygen. The free radical oxygen reacts with O2, creating ozone. The bond in ozone can then be broken by a photon equal to or shorter than 320 nanometers, resulting in an O2 molecule and another O free radical. The final step in the Chapman cycle is that an ozone and a free radical O can bond, resulting in 2 O2 molecules, and this is a closed cycle. This would be a perfect model of the cycle. However, investigations in the ozone hole above Antarctica, beginning in the 1980s, have shown that other atoms can interfere with and effectively inhibit this cycle, like a chlorine free radical, as a result of the molecular breakdown of CFCs, reducing the net production of stratospheric ozone, leaving the surface of our planet more susceptible to the potentially damaging high-energy electromagnetic radiation from the sun. In 2013, according to NASA, the ozone hole is over 8 million square miles. Life on Earth has evolved because of the balanced conditions of the ozone layer. As I will illustrate here, some species are more susceptible to these damaging effects than others. The normal extinction rate for amphibians is that one species will go extinct every 500 years. Since 1980, we have seen over 200 amphibian species disappear globally, and approximately 1/3 are regarded as high-risk or threatened species. There are an array of reasons for why amphibious species like frogs and salamanders are going extinct much more quickly than what we would naturally see, including pollution and climate change. Frogs are regarded as bioindicator species, meaning they act as something like a health meter for their ecosystem. This is mainly because they require both aquatic and terrestrial habitats, they have unique embryo development, and they have semi-permeable skin and eggs, which can absorb toxins easily, making them extremely good indicators of environmental stressors. Climate change caused by ozone holes and ozone thinning create both direct and indirect problems for amphibian species, resulting in the loss of amphibian species globally. Some of the direct problems for amphibian species as a result of atmospheric ozone loss are because amphibian eggs lack a solid shell. They are more gelatinous and, as a result, much more sensitive to development disorders as a result of increased ultraviolet radiation. Their semi-permeable skin also gives these species an increased sensitivity. There are 3 ultraviolet wavelengths: UVA, UVB, and UVC. Because of the nature of UVB wavelengths, which are between 280 and 315 nanometers, and because of both the harm it causes to living organisms and the significant increase in UVB levels in the atmosphere because of the depletion of the ozone layer, it is the only one discussed in the studies I will highlight later on. Some indirect problems, like predator species moving up mountainous areas as a result of changing climate and upward shifting cloud coverage, has been known to allow for the extremely lethal chytrid fungus to reach higher elevations. Amphibious species diversity in mountainous regions, especially in tropical climates like Costa Rica, is very high. This host pathogen is an infectious disease and is increasing in mobility because of the changes in Earth's climate. Climate change has led to changes in the water levels in ponds in Yellowstone National Park. Many amphibious species rely on ponds to remain water-filled until their eggs have reached a critical point in development. Droughts in Yellowstone have reportedly increased, causing 25% of these ponds to remain dry. Yellowstone is a protected park, and yet its amphibians are still seeing a decline in populations. I will highlight 2 case studies all pertaining to the decline in amphibian population. The first study, conducted in 2000, called Sensitivity of Embryos in Southern amphibians to ambient solar UVB radiation. This study explains that ambient UVB radiation can kill or deform amphibian embryos, and that amphibians in high latitudes are at higher risk. However, they are affected worldwide. The study conducted a test using groups of amphibious eggs, 2 species in each of the 3 UVB filter environments. The first matured in an environment with a filter that blocked more than 98% of the UVB rays. The second group was subject to a filter that allowed for 80% transmission, and the final group was unfiltered. This study found that deformity rates for both species were significantly lower in embryos that were shielded from UVB rays than the unshielded controls. I discovered that amphibians are not usually just subject to one environmental stressor, and that a synergy between stressors tend to cause even further damage, especially during the developmental process. In a study called a pH UVB synergy in amphibians, the test subjects were now exposed to not only increased UVB radiation, but the eggs were to develop in conditions with decreased pH levels or higher acidity. While thinning of the ozone layer doesn't cause a decrease in pH levels, we can generally say that the ozone depletion and acidification are both caused by anthropomorphic processes. In this study, they separated the test subjects into 3 groups. The first had only the pH of the water decreased, the second had the UVB decreased, and the third were placed in both low pH water and had an increase in UVB radiation. The study found that the group that was subject to both environmental stressors had a much more significant increase in the embryo mortality rate. To conclude, ozone depletion causing higher levels of UVB, an increase in toxins, acidification, habitat loss, infectious disease, and pathogens are all causing a substantial decline in amphibian populations. All of these factors are caused by humans. Species like frogs are regarded as indicator species and can be studied to examine the health of our environment. Amphibians are going extinct at a far greater rate than mammals or birds, and a third of amphibians are at risk for extinction. If we wish to gain a better understanding of how humans are changing the environment, we should look to the susceptibility of these species as an indicator of the damage we are causing to our planet. And to finish off, I found a quote that I thought would really reflect this presentation. The frog does not drink up the pond in which he lives.